These are the Unit 9 quiz corrections on circles. Please remember to earn credit, you need to show all work on your copy of the quiz. All right, question number 1. Which of the following represents the value of x? So the first thing we need to do is decide what kind of angle is angle x. We see that the vertex point for angle x is on the circle. When the vertex is on the circle, that is an inscribed angle. The rule for inscribed is n half. That means if we could find the measure of this arc, when we take it in to the inscribed angle, we would cut it in half. But unfortunately, we don't have the measure of this arc. All right, so let's look carefully to see what else we do have. All right, I see that this point right here, the center, is C. So this blue segment that I'm going over is a diameter. A diameter cuts a circle in half. So these two arcs up here have to add to equal 180. So to find the purple arc measure, we have to do 180 minus 122. And if we do that calculation correctly, we'll get 58. All right, so let's come back and fill in. This missing arc is 58. And when we take it in and inscribe it, we have to cut it in half. 58 divided by 2 is 29. So x equals 29 degrees. To receive credit, you have to show all of the work. You have to show the measurements on the diagram. You have to show your thought processes. You have to show all of this to receive back any credit. Please do a good job. All right, question number 2. If the measure of angle CAB is 40, then which of the following represents the measure of angle CDB? All right, so let's outline. From the C to the A to the B is 40. That angle is inscribed. It has been cut in half. To bring it back out to the arc, we multiply by 2. 40 times 2 is 80. So arc CB would be 80 degrees. But that's not what they want. They want the measure of angle CDB. So let's outline angle CDB. I see the arc that it intercepts is 80. When you take the arc measure in and inscribe it, you cut it in half. 80 divided by 2 is 40. So the measure of angle CDB is 40 degrees. Please remember to show your work to receive credit. All right, number 3. When inscribed in a certain circle, triangle ABC intercepts arcs as shown in the diagram. Which of the following represents the measure of angle BAC? So let's outline and see where angle BAC is. I see that is an inscribed angle. but we do not have the measure of arc BC. So that's our first step. What is the measure of arc BC? All right, we know that the whole entire circle is 360. So if we do 360 minus 180 minus 140, that's going to give us this missing arc BC. And when we do that, we get 40. All right. Let's see. So we're going to take that angle in to inscribe it at angle BAC. Remember, A is the middle letter. When you inscribe, you cut it in half. 40 cut in half is 20. So the measure of angle BAC is 20 degrees. All right, number 4. Line BD is tangent to circle B, to the circle at point B. So y'all, let's notice where line DB intersected with segment AB, there's a right angle. That right angle is important. We don't really care about all these words, tangent and all that. We just care that, look, oh my gosh, there's a right angle right there. I'm going to make it bigger. Okay. Let's see. Let's keep reading. The measure of arc AC is 108. From the A to the C is 108 degrees. All right. I'm going to inscribe that 108 to angle ABC. When you inscribe, you cut it in half. 108 cut in half is 54. All right, let's see. Maybe we're lucky and we have the answer they want. Let's keep reading. Which of the following represents the measure of angle CBD? Let's outline from the C to the B to the D. We don't have that measurement yet, but I do see a straight line segment. Look right there. That's a straight line. We know that the 3 angles on that straight line add up to equal 180. So we're going to do 180 minus the 90 that was already there, minus the 54 inscribed angle, and that is going to leave us with 36. So the measure of angle CBD is 36 degrees. Well, that almost looks like a 360. Let me make that look better so you're not confused. All right, number 5. Quadrilateral PQRS is inscribed in circle C. We know that when a quadrilateral is inscribed in a circle, opposite angles are supplementary. Please write that down. Please ask yourself, what number do you think when you see supplementary? Hopefully you thought, yeah, I think 180. Okay? Supplementary, 180. So opposite angles add up to equal 180. All right, let's see. They want measure of angle R. So let's see, what is R opposite from? R is opposite from P. That means angle R plus angle P equals 180. Okay, fill it in. Angle P is 58. Good grief, come on, Miss Ratliff. P is 58. All right, you could just subtract 58 from both sides to solve for r, or you can change that r into an x and type it in Desmos. Okay, whichever way you decide is fine, but what you're going to end up getting is angle R equals 122 degrees. Remember, these three little dots mean therefore angle R equals 122. All right, number 6. In circle C, PC equals 7. Okay, that gives us the radius. The measure of arc PCQ, I'm sorry, y'all, let me try that again. The measure of angle PCQ is 140. That is a central angle. A central angle is equal to its arc. Okay, therefore, this arc PQ is 140 degrees. All right, let's keep reading now. Let's see, what do they want? Find the length of arc PRQ. They want the length of the rest of the circle. Well, first we have to find the degree measure for arc PRQ. We know that a whole circle is 360. Subtract that 140, and the measure of arc PRQ is going to be equal to 220 degrees. Oh, come on. But unfortunately, that's not what they want. They don't want the measure, they want the length. So you have to go use your length formula. The length is equal to the degree measure of the arc, 220, divided by 360 times 2 times pi times the radius, which is 7. And if you plug all of that into Desmos, you're going to get 26.9. All right, we rounded to the 10th, so we are good to move on. Number 7. Solve for x and solve for y. All right, I noticed that they have given me the center of this circle is point O. That means that angle BOC is a central angle. The slogan is, take it to the center, it stays the same. All right, since arc BC is 54, when we take it to the central angle, it stays the same. So x equals 54 degrees. All right, now let's look at the other angle, angle Y. All right, let's see, Y has side AB, and it also has side AC. And the vertex point A is on the circle. When the vertex point is on the circle, that is an inscribed angle. And the slogan for inscribed is in half. So when we take this 54 all the way and inscribe it at the Y, we have to cut it in half. 54 cut in half is 27, so Y equals 27 degrees. All right, number 8. The measure of arc ACD is 280 degrees. Let's go fill that in. ACD is 280 degrees. The diameter of circle E is 30. If the diameter is 30, then the radius would be half of 30, which is 15. We're lucky they've already filled that in for us. Find the area of the shaded sector. Leave your answer in terms of pi. All right, so let's write down the area formula and get to work. The area of a sector is equal to the measure of the central angle A divided by 360 times pi r squared. All right, but we don't know the measure of the central angle. We don't know the measure of the arc that goes with it. So that's what we need to work on right this minute. We need to find the measure of arc AD. We know that a whole entire circle is 360. If we subtract 280 for the major arc, that'll leave us 80 degrees for minor arc AD. All right, a central angle is equal to its arc, so we have A is 80. We're going to divide that by 360 times pi times the radius, which is 15. That was up here. It's also in the diagram. Don't forget to put the square one because the formula says so. All right, now what are we going to do with this in terms of pi? In terms of pi means do not put pi in your calculator. You're going to put it on your paper on the answer. So what am I going to type in the calculator? I'm just going to type in 80 divided by 360 times 15 squared. Don't put that pi in the calculator. Okay, so just put in the fraction times 15 squared. And let's see if I can find that answer on my paper. That turns out to be 50. And then look, they've already got the pi there. It's teeny tiny. I wish that that was bigger, but y'all, it is what it is. It says in terms of pi, your answer would be 50 pi. The pi is already there. All right, number 9. The city is building a new outdoor theater. They need to know the area of the shaded region so they can install seats. Find the area of the shaded region, round to the nearest tenth. The radius of the stage area for the small circle is 20 feet. That's right here. And the area of the concrete portion where the seats will be installed is 50 feet wide. They want us to find the area of the shaded region. All right, to do that, we're going to find the area of the larger sector minus the area of the small sector. All right, so for the large sector, y'all, that would be, here's what we're looking at. It's if I had this whole, that pink is not showing up at all. Let me try again. That would be if I had the whole entire slice of circle colored in, what would be the area of that green portion? Well, area is A over 360 times pi r squared. Okay, A is the measure of the central angle or the measure of the arc. Since the central angle is 110, I know that the arc for the larger sector is also going to measure 110. All right, so I'm ready to plug in. 110 divided by 360 times pi. All right, what is the radius for the larger region? Let me recolor my green back in. How long is the radius for that part? Altogether, it's 20 plus 50, which is 70. All right, so let's get rid of all that. All right, now we have to do the area of the small sector. The small sector would be this little part in here, this little slice of the circle. Its central angle is 110, so its arc would also be 110. Divided by 360 times pi times the radius for that little section, that would be 20, and the formula says we have to square it. All right, so just take a minute and go type all of that in Desmos and round to the nearest tenth, and you should get 4,319.7. And the answer already has feet squared on it to let us know we're finding area. All right, number 10. Oh my gracious, I couldn't find it. It was so small. Number 10. In circle O, AD is a diameter. The measure of angle CAD is 33. Find the measure of arc AC. All right, well, let's see what we have. This angle CAD is an inscribed angle. It has been cut in half. To move it back out to find out the arc, you multiply by 2. 33 times 2 is 66. So the measure of arc CD is 66 degrees. But that's not what they want. They want the measure of arc AC. All right, let's go back and read. They tell us that AD is a diameter that cuts a circle in half. That means that this semicircle over here is 180. And we know that a whole circle has 360. So to find the degree measure of arc AC, we're going to do 360 minus 180 minus 66. And if we do that, we're going to get 114 degrees for the measure of arc AC. All right, number 11. This one was tough. In the image below shows two concentric circles with center O. CO is equal to half of AO. We'll come back to that in a minute. And look, they give us a right angle. Angle AOB, the central angle is 90. All right, we're going to come back to all that. Here's where we're going to start. The area of the larger circle is 36 pi square inches. Let's start right there. To find the area of a circle, you do pi r squared. We're going to take out the a and replace it with 36 pi. Okay, you could do all of your algebra and inverse operations, or you could type this in Desmos and put pi times x squared, and you would get that x equals 6. Therefore, the radius is equal to 6. Okay, this is the radius of the larger circle. That's important. So let's come back. The larger circle, the radius is AO. That's going to be 6. All right, now let's come up here and see what we have. The next thing they tell us is that CO is equal to half of AO. CO right here is half of 6. To cut a number in half, you divide by 2. So CO is equal to 3. All right, now we're going to do, let's see if I've got room. I do. Let me make this smaller. All right, I can do it right over here to the right. Now what we're going to do is we're going to find the area of the larger sector minus the area of the smaller sector to find the area of the shaded region. Okay, so remember the large sector would be this whole entire slice of circle. Its central angle is 90, so the arc measure is 90. So that would be 90 divided by 360 times pi times its radius square. The radius for that large sector is 6. All right, let's erase all that green. Okay, now we have to do the small sector. Excuse me, the small sector would be this little slice here in the middle, the smaller piece. Excuse me. Its central angle is 90, so its arc measure would also be 90 over 360 times pi times its radius squared. Let me get rid of some of this. The radius of that little small sector is 3. So we're going to put times 3 squared. All right, now I'm going to try to work smarter, not harder. I'm going to look at all my answers. All of my answers are in terms of pi. So we're going to leave the pi's out of our calculator, but put it on our answer. All right, so if you type in what I have highlighted, 90 divided by 360 times 6 squared minus 90 divided by 360 times 3 squared, you're going to get 27 over 4. Then you have to put the pi on your answer. And what were we measuring in? Inches. So this would be inches squared. That one was tough. Y'all, the part that gave me a hard time is they're talking about all these sectors, but then they said the area of the larger circle. They didn't say the larger sector, they said circle. So we had to start with the circle area formula. A lot of times it's about reading carefully to understand what they're asking us to do. All right, and let's see. I think we are almost done. Number 12, the last one. Let me make this big again. Circle O has a radius of 3 units. A central angle of the circle has a measure of 60. What is the length of the minor arc intercepted by the central angle? This is all vocabulary. They want you to draw a picture for all of this information. So we start by doing our best to draw a circle. At the center, put O. Make a central angle. That central angle has a degree measure of 60 degrees. Therefore, the arc is going to be 60. They want the length. Length equals A, that stands for either the central angle or the arc, divided by 360 times 2 times pi times r. And there's one little piece that I need to remember to go back and get. The radius is 3. So let's fill this all in. That would be 60 divided by 360 times 2 times pi times 3. All right, let's look at the answers. They have pi in every single answer. That means we do not put pi in the calculator. because they've put pi on every single answer. So what we're going to type into our calculator would be 60 divided by 360 times 2 times 3. And if we do that, we're going to get 1. But don't forget, we got to put the pi on it. 1 pi is just simply pi. So the answer would be pi, which is answer choice A. Remember, there's understood to be a little 1 there in front of that pi. Final answer, number 12, is 1 pi, or simply pi units. All right, that's the end of the quiz corrections for Unit 9. Please let me know if you have any questions about what I have presented in the video.